Okay, so welcome to today's boring session where we cover some of the basic stuff that you should have known, which is circles, arc and sectors, and surface area, volume, and a bit of capacity, which is pretty much almost the same thing as volume. They're interchangeable. Um, I mean, not exactly very close, but like they're quite the same thing. This is just probably the world problem solving version of it. Okay, so in a circle, you must know that if their radius is in r, and you want to find their circumference or their perimeter, then it would be 2pr. And then if you want to look for their area, this entire thing, then that would be pr squared. And if in a circle you have, you have this degree, you have theta degree, and again the radius is in the form of r, and you want to find the length of this portion of this perimeter, which is called arc length, then you would need to times you would need to multiply the circumference formula by the angle ratio. So this would be theta over 360 times 2pr. And then for the area, you also need to do the same thing because you're only looking for this portion. So you multiply the area by this ratio. So it's like this, pr squared. Okay, so that's literally it for circles, arc, and sectors. Now, there are further, there's going to be more advanced stuff in relation to it later, which is if we use the theta as form of radians, but I don't think it's appropriate to cover that right now. Probably in future math sessions. Okay, so now we're gonna go into surface area. So if you have a 3D shape, whether it's a cube, it's a rectangular prism, it's a whatever prism that you have. For example, this prism. Yeah, if you have this kind of prisms, and you want to look for its surface area, yeah, like this, and you want to look for its surface area, an easy way to do it is you look for the base area, and then since there's two base areas, and you're trying to like cover all the surface area, you look for the base area times 2, and then you add this base area with the perimeter or the perimeter of the base times the length, or its height, this part. Because if you're looking for the perimeter of the base, and then you times it by its length, it's kind of like saying that you're pulling out, you're making up like a big strip of the entire perimeter, and you times it by its length, and that is an easy way for you to look for the sides of it. And for the base, since you've already covered this part and the back part, then you found all the surface area. But for surface area, there are also other exceptions like the sphere and the cone. So for sphere, the formula is 4pr squared. I don't know why, it's just like that. And then for the cone, the formula is PRS, this is the slant, plus PR squared. So there are times when they don't give you the slant. So but sometimes they would give you the height of the cone. To find the slant, basically you just need to think of this thing as a triangle, like height RS, and then use the Pythagoras formula to look for the slant. And that's pretty much it. So for these, in problem-solving questions, there are times indeed where when they ask for you the surface area, they would say that, for example, they ask you for the surface area of a cone. They would say that it's an open-ended kind of cone. So you have to pay attention to that and make sure that you exclude the base area of this particular shape, because they're not asking you to look for the base area, but rather only the sides of it. Or another example would be if they ask for the surface area of an open-ended box. So in this case, if they're asking you for an open-ended box, that means that the surface area would be something like, for example, if this is x, it's going to be 6x squared minus x squared, so that would be 5x squared. This they're going to ask you to include everything except for the top part, because it's not going to be covered, and therefore this part is not going to be included when you're calculating it. So surface area is pretty easy. You just need to pay attention to the word problem, because sometimes there might be variations in the word problems. And then for volume, volume is essentially the amount of space a shape occupies. So if you have a general shape, like maybe like a cube or a general prism, then the way to look for it, would be to look for the area of this part multiplied by the length. It applies to any kind of shape, as long if it's a prism. Like if you have triangle, if you have triangular prism, if you have pentagon, and etc. As long as you look for the area of the base and then you times it by the height, that's literally how you find the volume of it. And then for sphere, they have a special volume, which is 4/3 times PRs to the power of 3. For shapes like pyramids and cones, this they are they slowly, like, they have an edge in one side, but then they form into, like, they increase in the shape of, like, turning into their base, like this. You usually do it like the prism formula, except you add a 1/3, because if you kind of like if you kind of think about it, the shape of the pyramid or the cone is this. If you try to cut it and I guess try to fit it in like a box shaped kind of thing, like a flat shape, it would be like a third of their initial height. And then capacity. Capacity is the quantity of the fluid that the shape is capable of holding. So capacity and volume is actually the same thing. Like if you have but the difference of it is that, for example, if you have this kind of cube and you want to fill it in with some tap water, then the volume of the water wouldn't fill up the entire capacity of the cube, because the water is only, in this case, the water is only half of the cube. So in the sense that if you have like problem solving questions, the volume kind of depends on whether you have like a certain fluid or something. Because if you do, then the chances are that most likely they ask you to look for the volume of the entire thing, or they probably would ask you to look for the volume of the liquid, which doesn't fill up the entire capacity or the entire shape itself. So there are differences in terms of units, I think. Yeah, in terms of units. So usually for general calculations, we use the metric, right? And in terms of volume, we usually use cm3 or m3. But for capacity, they usually use milliliters or liters. Um, and if you like to convert that, cm3 is equal to milliliters, while meter cubic is the equivalent of kiloliters, or wait, 1 kilo, yeah, kiloliters, or usually 1,000 liters. So that's usually pretty much it for all of these. Okay, so for this, it's probably better to like just jump right into the questions. There we go. So can do